Yeah,
Yeah, how do I view the recordings? Like, do you all send it in, or shall I view it from my portal or something?
right. So normally, uh, our course coordinator, they send via email the link to the recording. However, we'll make sure that the link to the recording should be available, uh, on the Moodle.
Okay, perfect.
Yeah,
Thank you. Yeah.
welcome. Right. So as you know that there are 6 units, yeah, into your course, and
Yeah.
software engineering is one of them. Yeah, and
Yes.
I believe you have done your level 4 earlier.
Yeah. I've
Okay,
done it from IQN, but not from OTHM.
okay, good. Yeah. So before I, start the software engineering itself, yeah, would you like to
Yeah.
tell me that what good subjects and you have studied so far?
Basically, actually, I have done in my high school 2 years of multimedia and web technology. So there
Okay,
I've learned all about web application development like HTML, PHP, JavaScript, and
good.
some basics of like SQL. Although I want to focus now more on like, I'm not sure which is the language, but I want to learn about which softwares do companies use, how to design Oracle kind of templates, SAP. So I'm
Yeah.
not sure of what the languages are, but I want to learn about that.
Okay, I understand what you mean. Yeah. So
Yeah.
like the framework, SharePoint, and uh,
Yeah.
yeah, there are lots of other frameworks, and they really you don't need to reinvent the wheel, but you can be
Yeah.
master in them.
Okay.
Yeah, so that's good. Yeah, so I can understand what you want to do, as well as basically the field of computer science and the information technology.
Yes.
The computer science was the origin. Yeah, it was
Okay.
based on the theories and concepts, and some practical implementations. They have given a form into IT, a kind of. Yeah, so
Yeah.
information technology itself is consisting of the software, hardware, networks, many things. Yeah, but
Yeah.
the logic behind is science, computer science, like computing is the main thing. Yeah.
Yeah.
So
Yes.
yeah, so the reason I asked, so there is a need of little introduction into the software engineering. Yeah, so
Yes.
that's why I inquired. So let us start. So maybe from some definitions it would be fine to go ahead with. uh,
Okay.
yeah, so apart
Yeah.
from software engineering, yeah, have you
Yeah.
done like any other programming language?
No, no programming languages till now.
Okay, except the HTML, and you have done
PHP, JavaScript, CSS. Like it's all based like basically web development.
yeah. Okay. However, the JavaScript itself is a the programming language, yeah,
Okay.
and that's done into the Java indeed.
Oh, okay.
Yeah, because the code of Java is used into the JavaScript, and the methodology, methods and variables, all the you know those
Syntax. Yeah.
syntax, yeah, you use into the JavaScript, in JavaScript. Yeah. So
Oh.
did you just try the JavaScript using certain tools, or you did really code yourself?
I actually did it basically just through simple notepad and then executing it on internet.
Okay.
So I actually did the codes myself.
Okay, that's fine. Yeah, good. So now, normally what happens, the HTML or the other markup languages, even the XML, they are
Yeah,
not executable. However, when you call, when you need a certain functionality at the browser side, then you need
yeah,
a kind of scripting. Yeah.
yeah,
So scripting is basically like it has a functionality. Yeah.
Yes.
They like, if you are clicking on any button, if you are hovering any button, if you are,
Yeah.
doing
Based
any,
on the event.
yeah. So behind that, those actions, you normally get, your code is executed,
Yeah.
right? So that's why, certain programming language, yeah, is working behind. So that's fine. And I hope, you should start learning the any programming language as well, and I can
Yeah.
give you the directions, and we will have a look into the course. If any of the programming language is mandatory, I believe some of them are, some of the units, they require you to create a program as well. So
Okay.
yeah, so we will be working on it. Yeah,
Okay. Yeah.
right. So
Oh,
yeah, do you have any question?
no, no.
Okay, that's fine. So now the software engineering, yeah.
Yeah.
Uh, do you want to say something about it?
Basically, what I feel is that software is when you put in programs together and how you develop them and
Okay,
how you build its functions.
okay. Can you develop the programs without software engineering?
No, no.
Are you sure?
I've not heard about that as of now.
Right. Basically, the software engineering is the development of software, yeah,
Yeah.
using disciplined manners and steps,
Okay.
right? So even the software used to be built when there were no concept of the software engineering,
Oh, okay.
right? So software is the systematic way of developing the softwares,
Okay.
right? So let us, go through some very good definitions, that I have put into the slides, so that you should be able to, be aware of those definitions, as well as those definitions are the standard market, terminology as well.
Okay.
So here, the LO1 is understand the modeling languages and their benefits. Yeah. So
Yeah.
there is a little bit of quick, jump into the LOs. Yeah.
Yeah.
Like you might have noticed that it's directly going into the modeling language. However, it should have been going,
To the
uh,
basics, but
to the
yeah.
best. Yeah. Probably the reason may be that this is the level 5 course, and there is an assumption that someone who is in the level 5 must have studied the basics,
Yeah.
right? So no worries. And I have tried to add few slides into the definitions and the reason and the way how we have reached into this stage.
Okay.
Okay. Now, the aim of the unit simply give learners an understanding of the software development and its evolution as an engineering discipline, right?
Yeah.
So the evolution is the gradual development. You will be developing the software slowly and gradually, right?
Yeah.
So gradually means there is no any, abrupt, actions that you will be taking, but you would be taking and doing step by step, right?
Okay. Yeah.
Right. And then obviously to develop systematically, maintain and evolve software systems of high quality, right?
Right.
So now, before we go through the actual definition of the software engineering, now let us see a few of the core definitions quickly, so that
Yeah.
they should be revised only. Computer
Yeah.
programs and associated documentation. So software is always comes with associated documentation. Then you can say that it's a software. Yeah.
Okay. Yeah.
Software products may be developed for a particular customer or may be developed for any general market. Yeah, so there is a question and topic behind it, you might have studied into the introduction to computers, what is software and what are the types of the softwares.
Yeah.
Can you tell me what are the types of the softwares?
Application software,
Yeah,
utility software,
good. Yeah, like
and
yeah, yeah,
yeah,
yeah, yeah. Very good. So like the type of the software, application software, system software. Then in the system software you got operating systems, utilities, and debuggers in the application software. And there are again two types of the softwares. Yeah.
yes,
There's a little story behind, like in the application software, there are general purpose softwares, like you use word microprocessing, the word processing,
yeah,
presentations, and these things, and the specific purpose softwares you use, like the uh, eh, specific purpose like accounting, finance, and these type of
yeah,
softwares, right? So
yeah,
what are the attributes of a good software? Good software should deliver the required functionality and performance to the user and should be maintainable and usable. So if as a user your requirement is fulfilled, then it's a good software. Yeah. If it
okay,
is maintainable, then it's a good software. And if it is usable, easy to use, then it's a good software. But if it is not usable and not user friendly, then you can't say it's a good software. No
oh,
matter, yeah, no matter if you have implemented correctly and everything works, without any bug. Yeah, so these are
oh,
the basically characteristics of the software,
yeah,
right? Now, the software engineering itself is an engineering discipline. Yeah, so
yeah,
the word they have used, like as an engineering discipline, like this course, this field, this in discipline has also been added into the engineering universities as well. You must have heard about it.
yes,
However, like the civil engineering, electrical engineering, and mechanical engineering, and few more, they are called as a disciplines, yeah, of the engineering. In the
yes,
same, the software engineering is also counted as this engineering discipline, yeah,
okay,
that is concerned with all aspects of a software production.
yeah,
Like so, when you get any building constructed, yeah, so that's a production, and the software itself is considered as a production.
yeah, correct.
Yeah. Now, what are the fundamental software engineering activities? So, in the fundamental software engineering activities, you would be focusing on the specification, development, validation, evaluation.
Okay,
Yeah. Now,
yeah,
uh, maybe I would be, giving you the definition, oral definitions, little bit quickly. Yeah. But if
yeah,
you want me to repeat anything, then you are most welcome. You can ask me to repeat it. And yeah, and you
yeah,
will always have a chance to listen to the session if you think that you need to repeat the my conversation and whatever the definitions. Yeah, because I
yeah,
cannot put everything, all the definitions, into the slides. Yeah.
yeah, correct.
So specification, you need to specify what you want to do and what really you require in the software. Then you develop, then you validate, and validation, can you say something about the validation?
Validation, I believe, is to check if it's working well, if there are no errors, if it is meeting the standards, requirements.
Okay, yeah, that's correct. And can you tell me the difference between the verification and the validation?
Oh, verification, then I feel is checking if it is working, and validation is if it meets the requirements.
Yes.
Like verification
Yeah.
is the testing.
Yeah. Verification is the testing that whatever the software, uh, uh, whatever the requirements are, have you
Yeah.
implemented exactly which were required? And validation is that overall, if is it usable and serving the purpose or not.
Okay.
Yeah. So you must have seen these two words, verification and validation in some documents. Yeah.
Yeah.
Yeah. So that's the, that's good. I'm very pleased that you know about these, terminologies, and we will be able to go ahead, more quickly and confidently that you are able to understand. Yeah.
Thank you.
Welcome. Yeah. So what is the difference between the software engineering and the computer science? Like I explained earlier, the computer science focuses on the theories and the fundamentals. Software engineering is concerned with the practicalities of developing and delivering useful software. Yeah.
Yeah.
Now, the difference between the system engineering and the software engineering, like I said earlier, that everything is a kind of discipline. So system engineering is concerned with all aspects of computer-based systems. Like you can say that system engineering may be, called as IT information technology. Yeah, because it includes the hardware, software, and process engineering. For example,
Yeah.
to be honest, there is no any specific definition of the information technology. Have you heard
Yeah.
about
You
this?
can't separate it.
Yeah. Have you heard about this, discussion that there is no particular definition, and no grounds of saying a word information technology. Have you heard about this?
Yeah. Yes.
Yeah. Okay. So that's why I would be using this term, interchangeably.
Okay. Yeah.
Right? And software engineering is a part of this more general process,
Okay.
right? But however, like computer science used to be the base, and it is still the base,
Yeah.
right?
Right.
And moreover, like computing is not going to change that much rapidly, while the information technology is evolving and changing with the time very rapidly,
Okay.
right? Now, so if I would say that, can you fit, can you give a big picture of software engineering, then
Yeah.
probably the software development life cycle would be the number of stages, like 6 in front of you. Some of the, sometimes we split more into, detailed one. Yeah. Like
Yeah.
you do some feasibility, then requirement analysis, you further split the stages. You know what I mean?
Yeah.
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 So in big picture, when you say software development, yeah, it means you are referring to the software engineering. Yeah. And
Yeah.
you are looking into certain system or software development life cycles. Again, there is a terminology, interchange. Sometimes you say system development life cycle, sometimes you say software development life cycle.
Yeah.
Okay. So I hope that, it shouldn't be confusing in between, and the words are interchangeable.
Yeah. Okay.
Okay, good. So
Yeah.
by looking at this, picture, planning, analysis, design, development, testing, maintenance, yeah.
Yeah.
So these things are covered into the software engineering,
Okay.
right?
Sir, for the analysis stage, what do they exactly analyze?
Yes, that's a good question. Basically, they formalize the requirements. Yeah,
Okay.
they formalize the requirements and document it very well,
Okay.
right? I would say the analysis is basically the requirements.
Okay.
Yeah. So like I said, that at different books and different, authors, they split these, terms into maybe more than, two definitions and terms into, uh, uh, words like
Yeah.
development and implementation. Yeah.
Correct.
Like they are believing that they need to uh, integrate first, yeah,
Yeah.
and then implement it, yeah, and
Okay.
maybe the development could be the part of the individual components developed, yeah, and then
Yeah.
implement it. So like in your question, what is exactly done in the analysis is basically getting the requirements, yeah, and
Okay.
yeah, sometime you must have heard about the requirement analysis,
Yeah.
yeah, and like it's a discipline, like you must have heard about the feasibility study,
Correct. Yeah.
yeah, so planning would be the feasibility study,
Okay.
right? So like I said, that the IT and even the software engineering is a kind
Yeah.
of plan where everyone is trying to give the definitions, and they are trying to give a more they're trying to make the terminologies and things into standard,
Yeah.
right? And because of the variety of the ideas, the software development methodologies are are being introduced day by day.
Yeah.
Okay, so let us move to the next slides, and then we will be going into the details of these stages, and they should be able to give you a broader understanding. And but however, simply, if everything is related with the software development or
Yeah.
software engineering, you are concerned with the requirement, and then
Yeah.
you need to design it, then implement it and test it.
Okay. Yeah.
Now, the software development models. Yeah. Now, the
Yeah.
question arises here, like I said, that different authors, different developers, they believe that this uh, set of steps, like a software development cycle, should have been carried out through certain methodology.
Okay.
Like I said, somebody says, for example, uh, I'm going to make a software directly. I'm sitting on the computer, and I'm going to code it, and then once I will be done half of it, and then you can give me the rest of the requirements, and I will be changing into my existing software. You
Yeah.
know, what do you think that is it good to go ahead with in this way?
Yeah. Yeah. Of course. Yeah.
Like you have implemented the software and then you are asking the requirements.
Oh, the first is implementation. No,
The
we
first,
need to first check the requirements and
yeah.
then the implementation. The other way around.
But if somebody says, I'm very good, I'm expert into, the software, I'm expert into the implementation, and I know what kind of software you need, yeah. And let me, write some, code for you. I would give you the demo, and then you can change the requirements. And can it happen practically?
No, because like it always needs to be customized to the requirements, right?
Yeah, yeah, yeah. You're right. It always needs to be, the requirement should have been frozen and received first, and then you need to implement. But that that ideology is one of the school thought that you should go ahead in this way. But
Mm.
sometime those models are kind of, the old models, and there are certain disadvantages as well. For example, if the customer is not sure about the requirements at all, then how the customer would get an image of the software? It is you that you will have to give them a kind of prototype, yeah, and kind of, you need to work on it, and then you need to compare and extract their requirements. Make sense?
Yeah, like a sample kind of.
Kind of sample. So based on these kind of, interchangeable situations, yeah, the methodologies and the models have been introduced. Some say that, okay, that particular smooth, step by step, development is good and you should always adopt it. And some say, no, you can, take the steps, you can skip the steps and, do whatever you want to do. That's also the fact.
Yeah, correct.
Right? Yeah. So, now we talk about the software development models. The software development models are the various processes or methodologies that are being selected for the development of the project depending on the project's aims and goals. Like I said, maybe sometime if the user is not aware of any software, then probably you will have to produce something for them, yeah, and then they will excuse me, then they will have an idea and they should be able to give you the more clear picture of the requirements. Make sense?
Yeah, correct.
So that argument, yeah, that variation of the stages is basically the reason of giving you the more software development models and methodologies.
Okay.
Yeah, I think you are clear that why one methodology is why methodologies are been introduced, and which one is good, which one is not good, what are the advantages and what are the disadvantages. Yeah.
Yes. Yes.
Good. So there are many development lifecycle models that have been developed in order to achieve different required objectives. The models specify the various stages of the process and the order in which they are carried out. So the variety exists and depending on what they need. Now, have you heard about the waterfall, V model, incremental model, rapid application?
I've heard that the waterfall model is from the designing stage until the execution, but I've not heard of the others.
Okay. Basically, the waterfall model is a kind, as the name implies, that you need to go through step by step. Like you first do the requirement analysis, yeah. Then you do the design, then you do the implementation, then you do the testing, yeah.
Okay.
And you cannot go back to the any stage you have already passed up.
Okay.
Yeah. So like once water has been fallen, then it cannot go back.
Can happen again, yeah.
So like a natural truth, maybe the gravity of the earth is not letting the water to go,
go back, yeah.
Yeah. So that's a little bit, a name given to it. And however, V-shaped model or incremental model, they have some, variations into it.
Okay.
Yeah. Like agile model says that you should carry out the system development depending on the workforce you have.
Okay.
Right. So like waterfall model can be adopted by any individual. For example, if one person is doing or 5% are doing, but if you have got a software development company, yeah, and you have maybe hundreds of developers, then you really need to focus that which parts may be done before, yeah, and and you can really, interchange the development stages, and you can choose whatever you want, and whatever the risky parts are, you can do it first,
Okay.
right? So that is the logic behind the system development methodologies and the list of available, software development methodologies. And I will have a look. I believe that in this particular unit, we have not been asked to, discuss the depth of these, models. But however, you are, I would advise you that you can study these in advance. Yeah.
Okay.
And you might need one of the model for your assignment as well, and then you can discuss that which model you are choosing and what are the advantages
Yeah.
and disadvantages, and at any stage, they are, being used, they can be used. Yeah.
Okay.
Right. Now, modeling language. Yeah. So do you know
Yeah.
anything about the modeling language?
No, I've just heard about XML, wherein we make the tree structures to design, like for databases, we can make the tree structures to understand where what is there.
Yeah. Anything else?
No, I haven't done details of modeling languages.
Okay, no worries. So we are here to discuss about the modeling languages. Yeah.
Yeah.
Okay. So the software engineering and its core, like a first learning outcome, is the what are the modeling languages and what are the benefits of the modeling language. Yeah.
Okay. Yeah.
Now let us look at the definition first, and then you should be able to understand what is the modeling language.
Yeah.
And then I would, explain to you that where the modeling language fits into the software engineering.
Okay.
Right? A modeling language is any graphical or textual, also called artificial language. Yeah.
Okay.
That
Yeah.
can be used to express the information or knowledge or systems in a structure that is defined by a consistent set of rules.
Okay.
So, any graphical way of representing the things or textual kind of thing, like shorthand. Have you heard about the shorthand and stenographer language?
No.
Like, the uh, some clerks into the offices, or the news reporters. Yeah.
Yeah.
They don't. What do you think if somebody, because this is information technology and the age of what I would say multimedia. You are
Yeah.
able to record everything, very easily and quickly.
Yeah.
Previously, it was very difficult to record anything, and the speakers who used to speak, deliver any lecture or any message, the
Yeah.
the new, I would say, for example, any clerk who is
Okay.
listening to the officer, yeah, or any news, reporter, they
Yeah.
never used to write the complete sentences, but they used to use the shorthand languages. Like,
Oh.
yeah, if you want to write, that, like the alternatives and the short forms of any languages, maybe in symbols, and, it was easy for them to repeat it. For example, if they noted down 10 lines of the speech into their notebook. However,
Yeah.
they should be able to convert into 100 lines of the speech.
Oh, okay.
Yeah. So now the modeling language is any graphical language. You try to represent anything into the graph, yeah, or text,
Yeah.
yeah. So that's basically the artificial. You have made it artificially, isn't it?
Yeah, correct.
Yeah. That can be used to express any information. Yeah, you are trying to draw or write any information or knowledge or systems structure. Yeah.
Yeah.
Consistent set of rules. Consistent means the permanent, constant. Yeah, set of rules. They would not be, ambiguous into the meaning.
Yes.
Right? The rules are used for interpretation of the meaning of the component in the structure. So by using those rules, yeah, uh, you should be able to interpret what they really mean.
Okay.
Okay. Now the question arises that where does the modeling language fit into the software engineering?
Yeah.
Right? So are you able to answer now that where that would be fitting?
I guess in the designing phase.
Yes, in the designing phase. Yeah, as well
Okay.
as in the analysis.
Okay.
Basically, still I can give you, from my understanding and whatever I have studied so far, the
Yeah.
analysis, you really do the designing in the analysis as well. Yeah,
Okay.
but in the design phase, you give a more concrete form of the analysis.
Oh, okay.
Yeah, there is a little bit, uh, uh, naming contradiction. Yeah, but when you say that analysis and design, then you still draw something into the analysis, and when when you are going to do it into concrete, then you really give functional parts of designing of the functional parts.
Yeah.
Okay, this might be contradicting into, that earlier I said the analysis is the requirements, but requirements can also be illustrated into the graphs. Make sense?
Okay. Yeah.
Okay, so once you will be studying like a different modeling languages, then you would be able to see that how they fit and work together.
Okay.
Okay,
Yeah.
now so like you answered quickly that the modeling language fits into the design. Yeah, so we assume that modeling language fits into the design, and which is the phase of software engineering, right?
Okay.
Now simply, uh, it could be the graphical, textual, or any specific type. So graphical
Okay.
modeling languages use a diagram technique, yeah, with named
Yeah.
symbols that represent concepts and lines that connect the symbols and represent relationships, and various other graphical notations to represent constants. Yeah.
Yeah.
So anything into the graph. So you might have experience of, drawing any graph. For example, graph may be any rectangle, any triangle, any circle,
Yeah.
any oval, any arrow. Yeah, anything which
Yeah.
could be drawn through the any lines. Yeah, they normally call it a vectors. Yeah, that comes
Okay.
under the, graph, right?
Okay.
Then textual modeling languages may be used standardized keywords accompanied by the parameters or natural language terms and phrases to make computer interpretable expressions.
Okay.
Like I explained earlier that in the shorthand language, they use specific keywords, and from 10 lines of code they can write 100,
Convert.
10 lines of, discussion into 100 lines. Yeah. So again, that's a modeling, isn't it?
Yeah. Correct.
Okay. Then apart from the graphical and the textual, yeah, there
Yeah.
also exists, some specific type of modeling language as well, like algebraic.
Yeah.
Yeah. Algebraic maybe, it's you are not using any graph, you are not using any language. Maybe you could use any symbols as well,
Okay.
right? So there exist the behavioral, modeling languages, discipline specific languages, domain specific languages, framework specific, information and knowledge modeling, object oriented, virtual reality. So basically these are, the also the types of specific modeling languages,
Yeah.
right? So we don't have to go into the details of those specific modeling languages. We are only focusing on the graphical language modeling, yeah.
Yeah.
And one of its selected one is the UML,
Okay.
right? So that's clear now. Where does the modeling language fit? Yeah.
Okay.
In the software engineering, what are the types of the modeling language, like a graphical, textual, or any specific purpose? Yeah. And
Yeah.
then which modeling language we would be studying in this unit? That's the simple, our path.
Yeah.
Okay. But obviously you should be very well known with this, these types and the nature, and so that that's the requirement of the LO1,
Okay.
right? So there are lots of modeling languages in the field of computer science, project management, and system engineering. Have you heard about
Okay.
UML before?
No,
Not at all.
I haven't done it. I've just heard of the name, but not about the details.
Okay. Have you ever studied the flowchart?
Yeah.
So can you tell me a little bit more about the flowchart?
It's like a hierarchy to show the divisions and subdivisions, and
Yeah,
it's like features and concepts
yeah,
and
yeah,
its functions. Like if something works, yes and no, the
yeah,
diagram shows it.
yeah. Like, yeah. So I would say, like, uh, pictorial representation of some logic. Yeah.
Yeah.
Most of the time it used to be used into the some logic and the algorithms.
Yeah.
Yeah. Like you said, you need to take the decision, okay, and where do you need to start diamond decision, blah blah blah. Yeah. So
Okay.
this is one kind of a modeling language, a very basic, very initial, stage of the modeling. Yeah.
Yeah.
So list of other modeling languages, for example, behavior T, business process modeling, CK theory. There are lots of modeling languages. Yeah, but we are
Yeah.
only going to focus on UML in this unit,
Okay.
right? So it's not necessary that I may uh, 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 add the more slides on these other modeling languages. But you can
Yeah.
always, if you are interested to go through the other modeling languages, then you can do. However, Unified Modeling Language is a general purpose modeling language that is
Okay.
an industry standard for specifying software systems.
Okay.
Right? Now here is an important word, that at the moment it is the industry standard.
Yeah.
Yeah. So why industry standard? Like most of the industries would accept your modeling, the design you created into UML, right?
Okay.
Yeah. However, we cannot say that it is a theory, for example. Yeah. And a
Yeah.
theory is the principle which is proved, yeah, and has become a fact so far, like other subjects in the, let's say, in the chemistry, physics, and the laws. Those are the theories. Yeah. So,
Yeah.
like I said, there is a variety and of opinions into the software development and the methodologies. Yeah. So again, the UML is the one of the modeling language, which is a kind of standard, industry standard.
Language. Yeah.
So UML 2.0, the current version supports 13 different diagram techniques and has widespread tool support.
Okay.
Yeah. So obviously that there are diagrams, diagramming techniques used into the UML.
Okay.
Right. Now, before we go into the UML details, yeah, and
Yeah.
there are the rest of the slides are being discussed for the UML diagrams, yeah, and
Yeah.
let us discuss one more important topic, which is the benefits of using modeling language,
Okay.
right? Can I ask the timing? Should I finish the session exactly at 11 o'clock UK time, or you would be flexible to recap the session even after 5 minutes later?
Yeah, 5 minutes is okay.
Okay, that's fine. Yeah. So
Oh,
I would try to finish everything by 11, and maybe a couple of minutes to recap everything.
okay, yeah, sure.
So benefits, some general benefits of using modeling language are: it improves the productivity of the development team.
Yeah,
Okay, makes sense,
yeah,
because everything would be, if the development team is working on a software, and if they have but if they have got a big picture of the system they are going to develop, then their productivity would be improved. They would really be able to know what they are going to produce, and they would be able to do it efficiently, isn't it?
yeah,
It reduces the number of defects in final code.
yeah,
Yeah. It improves the understandability of the system, uh, uh, which between eases the integration of the new team members. Yeah.
yeah,
It increases the decomposition and modularization of the system.
okay,
Yeah. It facilitates the system's evolution and maintenance.
okay,
It facilitates the reuse of the parts of the system in new projects.
yeah,
Yeah. So I think that the benefits, they are self-explanatory, and I don't need to explain maybe at this.
yeah,
Yeah. Okay,
yeah,
good.
got it.
Yeah. Now let me move to the other part. Now,
Yeah.
I'm going to start the UML formally. For example, a UML is an
Okay,
acronym for Unified Modeling Language. Yeah. Simply put,
yeah,
UML is a modern approach to modeling and documenting software.
yeah,
Okay. The word used here is modeling and documenting software. What do you
yeah.
think about the documenting?
Finalizing the designs and modeling.
Yeah, finalizing means like once the part of the document, a part of the modeling language that you use during the development, yeah,
Yeah,
as well as after the delivery, yeah, you need some documentation about the usage and the structure, and like a document guide, user guide, for example. Yeah. So
okay,
those diagrams are also being drawn into the UML.
okay,
Yeah. It is based on the diagrammatic representation of the software components. Yeah.
okay,
How you represent the software components, those are the diagrammatic. Yeah. We won't be, because diagrammatic, like graphical components,
Okay.
right? So good. Now, unified modeling language, the types of the UML diagrams. Like we said, there are like a 10 or 13 diagrams, types of the diagrams. Why there is a variation, like UML 1.1, UML 2.0, with the passage of the time, some of the
New
diagrams
structures.
have been added to it. However, the core diagrams still remain same.
Okay.
Yeah. Have you heard about the any class diagram, object diagram, component diagram?
No, no.
Okay, no worries. And have you heard about the object-oriented programming?
Yeah.
So can you tell me the difference between the object-oriented programming and non-object-oriented programming?
I think what I've heard about object-oriented programming is it's related to the each element of the screen is an object and its functions are used in OOP,
Okay. And
unlike the other one.
any other definition or any other way to explain this?
No, no.
Basically, let me try to explain to you the difference between the object-oriented programming and non-object-oriented programming is initially the programs used to be in machine language. Yeah. Machine
Okay.
language, like very hard to understand, because computer is made of the uh, digital elements, digital things, like binary numbers, zeros and ones.
Yeah.
Have you studied the introduction to the computer and the
Yeah, ARPANET.
yeah? So by starting from that idea, computer is digital, and digital representation is done into the on or off, 0 or 1,
Yeah.
right? And when you do focus on the 0 and 1, then the softwares internally are written into zeros and ones. Yeah, they are called the machine language. And the machine language initially used to be very difficult to understand, and then they introduced the high level language. You must have heard about the high level language.
Yeah.
Yeah. And then before the high level language, there used to be the low level languages, like assembly language. Like there used to be a name given to the numbers, zeros and ones, to English names,
Okay.
right? And then slowly and gradually, when apart from those difficult computer software languages, when the programmers tried to give a flavor so that not only the computer could run, but the programmers could write their own programs. Let's say they introduced this assembly language. It was little bit difficult. I would say simply that those were not the structured programming languages, because at that time the structures, more easy to use code was not available, in simple words. Yeah. Then they
Okay.
introduced the modular programming. They introduced the functions. Yeah. And
Okay.
even after the modular programming, it was not easy to manage the big programs. Yeah. And
Okay.
then they introduced to incorporate into the things, into the objects. Yeah.
Okay.
When they really wanted to make the things to uh, make the similarities between the real things, they thought that they introduced the object oriented language, so that
Yeah.
every object should be included into the software. It should be independent, and like object orientation object-oriented programming language has the capabilities of encapsulation, polymorphism, and inheritance, characteristics. Yeah,
Okay.
those were incorporated into the design of that particular language. However, these features were not, existing into the older languages. Right?
Okay.
Now, the UML is the diagrammatic language that is based on the object orientation concept.
Okay.
Right? And class is one of the component of the object oriented thing.
Yeah.
Right? So class,
Yeah.
the UML you would be learning. Now there are two types of the UML diagrams. One are the structural UML diagrams. Those diagrams would give you the structure of the components. For example, the component of the class. Yeah, the
Yeah.
diagram of the class, the diagram of the object. Yeah, when you define the class, it is an abstract. When you create an entity, it becomes the object. I'm sorry, maybe I would be giving you the more vocabulary regarding the programming. Yeah, but
Yeah.
you can always, repeat those words in the recording, and you can read further,
Yeah.
whenever you want. Then
Oh.
composite structure diagram, you are going to deploy the package diagram, profile diagram. So they show you basically the structure of your analysis and design, right? The
Yeah.
other one is the behavioral UML diagrams, right? The behavioral UML diagrams like activity diagram, use case diagram, interaction and overview diagram, timing diagram, state machine diagram, communication. So you want to show how the software components would be behaving. Is that clear?
Oh. Yeah.
And the first one was the structural.
Yeah.
Now, in the requirement, there are two things most of the time. In this scenario, you would find the nouns. Yeah. Nouns
Okay.
would be the classes. Yeah.
Okay.
And verbs would be the use cases.
Okay.
Yeah. So nouns would be the classes and the verbs would be use cases, and you play around with these things.
Okay.
Right. Now let us go through quickly. The class diagram looks like that. The client is a noun, account is a noun, and obviously there is some association between the classes as well. Yeah.
Yeah.
Object diagram, when you really create the instance of an object, the instance of a class, then you get an object, then you see you have assigned the values.
Okay.
Yeah. Components, you can see that how those components are, staying and what is the boundary in between them. Yeah.
Okay.
You are going to deploy into the packages. For example, there is a bank server, there is a real estate server, which components reside into which component. So that's basically the deployment one. Yeah.
Yeah.
Use case diagram, like I explained. Yeah. We're now on the behavioral. Any verbs. Yeah. The verbs would become the use case, and those would be done by the actors. Yeah. So here the customer is the actor. Yeah.
Okay.
The oval or the use cases. Yeah. And you can see that these are number of actions like view items, make purchase, complete checkout, login. These are the verbs, right? Now activity. Yeah. So we are talking about the behavioral UML diagrams. Yeah. So activity like author would write the post, revise the draft. Yeah. And maybe the editor could do the draft, and both can be done by, let's say, author and the editor, or jointly they can do this activity, isn't it?
Okay. Yeah.
Editor has some other roles like needs a revision, taking decisions, and the publisher task is given here.
Okay.
Yeah. So this gives a very much clarity of the behavior involved, isn't it?
Yeah.
Okay. Then communication diagram, then the question arises that who would be communicating with the other one. Then certain diagrams are used and certain, techniques, and further, discussion is behind these, objects.
Yeah.
Yeah. So we are, like I said, we are not going into the detail right now, and just I'm giving you the overview of these things. And I believe the next LO is
Yeah.
getting the UML diagrams. They haven't asked us to create more all of the diagrams, but they have asked to produce the class diagrams. Yeah.
Okay. Yeah.
But obviously you have to master into everything, isn't it?
Yeah.
Right. So communication diagram, sequence diagram, in which sequence those classes and actors would be triggering the sequence.
Yeah.
Right. A state diagram, the state, in which state particular those stages would fall.
Okay.
Right. And XML basically is the markup language used to describe the data. Yeah. The XML
Okay.
standard is flexible way to create information, formats, and electronically share structured data via the public internet as well as via corporate networks. Basically, the XML is not the modeling language. Yeah.
Yeah.
So they have just added. You must have seen the uh, unit specification XML is included, isn't it?
Yeah. It is.
So, but that is not the focus of the modeling language at all. Yeah. But just I gave you a little introduction that XML can be used as a data model as well.
Okay.
Yeah. But there's a too big discussion and idea behind the usage of XML. So we the XML is not required into the assessment as well. So we are not going to touch anymore. Yeah.
Okay.
Yeah. Now, so uh, now question arises that what indicative reading is required. So you must have you seen the list of books?
Yeah, I've got 2 books for now on the portal for software engineering.
Okay, good. Yeah. So I'm very pleased to share with you that I should be able to send you the all books as well.
Okay.
Yeah. Like using UML, software engineering with UML and VLC, developer testing, as well as I would recommend you, as well as I will send you the soft copy of software
Okay.
engineering by Sommerville and UML distilled by Martin Fowler.
Okay.
Yeah. So
Okay. Thank you.
yeah, welcome. So you should be able to read these, in detail, and let me know if you have any difficulty of any resource or any understanding from the unit. You can ask,
Yeah.
anytime in the next session via email. Yeah, and we will
Okay.
try to, cooperate you anyhow. Yeah,
Okay. Yeah.
right. So I end the session now, and I would see you next week. Yeah.
Sir, regarding the timing, can
Yeah.
we have it at UK 12 o'clock?
Yes. Yeah. That's fine.
Because that timing will be more easy for me. So next time onwards, every Wednesday,
Yeah.
UK timing 12 o'clock. So over here it will be around 2. Is
Yeah,
that
that's
fine?
good. Yeah, that's good. Yeah, even for me, it's sometimes it's little bit early, so it also suits to me as well.
Okay, perfect.
Oh, yeah. Anything else you want
So
to ask?
shall I send an email for it or shall I change it on the meeting invitation or something?
Say again. Sorry.
Shall I change the timing on the meeting invitation or something?
No, that's fine. I would let the the course coordinator, and they
Oh,
will schedule at 12 o'clock.
okay. Thank you so much.
No problem. Okay. Thank you. Bye.
Thank you so much. Bye.